Hello and welcome to Lecture 2 on Consciousness. So I'm going to pick up right where I left off. And I want to talk about the smart unconscious. So there was a great study by, I practice this name so much, Dijksterhuis and Nordgen, and they showed that unconscious processing is valuable for complex decisions where pros and cons are difficult to weigh. So I think we've all had the kind of eureka moment where you've been juggling a problem and you just cannot make your decision. And then all of a sudden one morning you're in the shower and you're washing your hair and boom, there's the answer. So my niece right now is at the UVO, and she's really debating what she wants to minor in. She's a mathematics major, and she's not quite sure what she wants to minor in, and she keeps going back and forth, pros and cons. She will have that eureka moment eventually, but what this study showed was that while some decisions are harder to make with the conscious mind, or the conscious mind is slower at making the decision, the unconscious mind can take care of it quite quickly. And so sometimes the best thing you can do when you really cannot make a decision is to just put the issue to bed. Sleep on it. I have the image of a mason jar, and when I have something that I just can't make a decision about, or I can't stop really reflecting on, I imagine myself writing it on a piece of paper, and then I put it in the mason jar, and I put the lid on it. And then I imagine myself putting it in a kitchen cabinet. And that's where it stays. For some reason, that's a really helpful strategy for me. Now, my unconscious mind will keep working on that problem. So this concept of sleep on it, there's actually science to back that up. Okay, so now we're going to look at altered states of consciousness during sleep. Now, sleep itself is an altered state of consciousness. It's an adaptive behavior. So if something is adaptive, it helps us survive and reproduce. We'll look at some of the neural mechanisms of sleep, and we will talk about dreaming a few lectures from now. So, the difference between being awake and being asleep has to do as much to do with conscious experience as it does with biological processes. Because if you remember, our basic definition of consciousness is that it is the result of neurological activity. So, we can actually measure brain waves while people are sleeping. I've had 3 sleep studies. They're pretty interesting. So, using an EEG, electroencephalogram, I think I said that correctly. I hope I did. Researchers can measure patterns of brain activity during the different stages of normal sleep. So you have stages 1, stage 2, and stage 3 of non-REM sleep. And then you have REM sleep. So please go to Moodle, and in the folder titled Chapter 4 Consciousness Lecture Videos, please watch the video called Stages of Sleep. Welcome back. So that should help you with where we're headed now in lecture. Our brainwaves change dramatically while we sleep. And so you're not going to be tested on beta waves, alpha waves, theta. So don't worry about the names of the brain waves. What I want to show you, though, is how drastically our brain waves change from stage to stage. So here we have alert wakefulness. What's fascinating to me is your alert brain is a lot like your REM sleep brain waves. They're both they are both beta waves. That's interesting to me, and we will come back to that. Now, just before you go to sleep, your brain starts to slow down. And the further you go into sleep, so here we've got stage 1, which is shallow sleep. Stage 2 is kind of medium sleep. You're not deeply asleep, but you're not in shallow sleep. And then we get to slow wave sleep, and this is your deep, deep sleep. So again, you don't need to know the names of the wave patterns. Now, each night we go through multiple cycles of the 4 stages of sleep. So stage 1, stage 2, slow wave sleep, and then these green ones right here are REM sleep. And as you can see, you go up and down and up and down and up and down multiple times each night. Now, how long we stay in a certain stage of sleep is different each cycle of sleep we go through. And then, so now we call stage 3 and stage 4 sleep. We've combined them into one stage, and we just call it slow wave sleep. And this makes sense. These brainwaves are a lot slower than what we're seeing in stages 1 and 2 and REM. So each cycle lasts 50 to 70 minutes, and each REM cycle lasts 5 to 15 minutes. The further into your night's sleep you get, the longer each REM sleep cycle. So your first REM sleep, which is when you dream, may only be 5 minutes long. But your final REM sleep could be as long as 15 minutes, 10 to 15 minutes. It lasts a lot longer. So with stage 1 sleep, you're beginning to disengage from your environment. You're closing your eyes, but you're also less attentive to sound. That's when you're feeling yourself kind of drift off. You're still, processing thoughts and stuff, but it's getting slower. Your mental imagery starts to become less intense. And there's 2 fabulous things that happen. These amaze me. And I want you to know these. Stage 1 is when you have what are called hypnagogic hallucinations and myoclonic jerks. A hypnagogic hallucination is the experience that some kind of stimuli is happening and it's not. This happens during stage 1. So often for me, I hear a text message go off because I use my phone as my alarm. So I'll hear my little notification sound, or I'll hear the cat, or I feel like she's jumped on the bed. Those are my most common hypnagogic hallucinations, and my mind thinks they're actually happening, even though they're not. It's really weird when I think the cat jumped on the bed and she's not there, but it's a hypnagogic hallucination. And interestingly, the brain, when it hallucinates, the brain is actually hallucinating. It's as if it's actually happening. So if I hear my phone alert go off, my mind thinks it actually did go off. Then I check my phone and there was no notification. I was hallucinating. So we have hypnagogic hallucinations and then myoclonic jerks or sleep starts. And people often call this the falling dream, where your whole body will shudder and it wakes you up and then you start going back to sleep. But also, if you're able to pay attention to it sometime, because you're falling asleep, so it might be hard to do, but you might find that your hand jerks. It just jerks, or your foot jerks, or your leg jerks. For some reason, my hips jerk. That's where my myoclonic jerks come, is in my hips. I don't know why. But those are 2 of the signs of stage 1 sleep. So if on the test I ask you, what stage of sleep do myoclonic jerks happen? You're going to say stage 1. Stage 2 sleep, now we're more disengaged from our environment. So we're less likely to hear things if sound is going on. We're not really having much mental imagery at all. We're much more disengaged from our environment. Now, there's two things that highlight stage 2 sleep. There's sleep spindles and K complexes. Ugh, where'd my thing go? Sorry. So, here we've got a K complex, which is just a big burst of brain activity. Only happens during stage 2. The sleep spindle is a fast spurt of brain activity. Only happens during stage 2. So if you're having a sleep study and they've got all the little electrodes on your head and your face, they will be able to tell if you're in stage 2 sleep by the presence of sleep spindles and K complexes. So we've gone through stage 1 and stage 2, which brings us to slow wave sleep. This is your deep sleep. I'm sorry, this should say that it's very difficult to wake someone in slow wave sleep. I'm sorry about that. So slow wave sleep is your deepest sleep. It's hard to wake someone up when they're in their slow wave sleep. You know, if your alarm goes off while you're in slow wave sleep, it takes a little more time for you to be aware that your alarm is going off, and you're much more, what's the word I'm looking for? It's much more disruptive. You're more, I guess maybe just confused because you're trying to come out of slow wave sleep into being awake in a very fast period of time, and our brain isn't meant to do that. So slow wave sleep is your deep sleep. Now this is when the body repairs itself, and we'll talk about that in a little bit. Okay, so as you can see, you get your slow wave sleep during the first half of your night's sleep. So right now we're looking at an 8-hour span of sleep. Your slow wave sleep happens that first half of the night. Your REM sleep is mostly the second part of your night. And with each cycle that you go through, your REM cycles get a little longer, a little longer, a little bit longer. So how your brain cycles through sleep changes throughout the night with each cycle. That brings us to rapid eye movement, or REM sleep. Now this is where vivid dreaming occurs, the weird dreams. This is also called paradoxical sleep because it feels like you're deeply asleep, but actually your brain is very, very, very active. So here we've got REM sleep. This one's a better one. Here we've got our REM sleep brain activity. That's a lot like wakefulness. During REM sleep, you feel deeply asleep. You're very disoriented if you're pulled out of REM sleep, if someone wakes you up during REM sleep. But your brain is incredibly active because REM sleep is complicated. You're focused on what you're dreaming about. You're living that dream. So you feel like you're deeply asleep, but you're simply in another altered state of consciousness. So each stage of sleep is an altered state of consciousness. REM sleep is not the same as being awake. They are different stages of consciousness. The focus of your awareness when you're awake versus REM sleep is very different. You might have the same beta waves, but what your brain is doing during those beta waves is very, very different. So each stage is its own altered state of consciousness. Thank you.